Hey guys, what's up? Today we'll be doing bus routes. This is a LeetCode hard problem, and in our 75 study plan series, this is one of the two hard problems. So let's see how this question wants us to do. Basically, it's saying that you're given some buses which goes to some bus stops. So it's saying that 0 at the bus goes to 157, and this sequence continues forever. So basically the 0th bus is going to be like 157, then 7 is again going to go 157, right? So say you wanted to go from to 8, bus stop 8. So from here you're going to get out at this bus stop and change a bus which goes to 8, right? This is the question. Basically it's asking how many times do you need to change buses to actually be able to reach at your location 8. So that's the question about, and it says that if this can never be possible, then just return me -1. Okay, that is good, clear. Now this is a graphing problem, right? We need to search for something. You cannot really employ other techniques here because it is not known. You need to search for something. So we are clear that we probably need some kind of graph, and then we need to either do BFS, DFS, which are the most common stuff we need to do. Okay. So in the DFS, the problem would be that how would you calculate these stops? If I just go to 7 and explore all its nodes, I'm not really calculating the stops. That would be another tricky part. But in the BFS, it's more so like levels, right? Everything has a level. So if you are aware about this binary search trees, not binary search trees, I should just say binary trees, then you can do like a level order traversal using BFS, right? Because it is able to like maintain that level and then insert only the next node, the closest one, which is all what BFS is about. So BFS is more ideal choice. I assume DFS can still be used, but probably would be trickier to come up. And in an interview setting, that would be really difficult until unless you have seen the question before, obviously, and have done it. So we're given a source, target, and a routes as a 2D array. So let's proceed with how it would work. So now we're choosing a dictionary data structure, which is basically a hash map for our graph. Okay, so now our graph would have a key. Key is nothing but a node, basically a unique identifier, and then we have a value which is just neighbors of this node, which is a typical graph, nothing really fancy. And we are saying instead of using list, I'm just going to use uh, hash set. Now, hash set actually might be, I guess, a worse choice actually in this case. But I just wanted to show that hash set can be used. The reason I said it's going to be a worse choice is because hash set doesn't have like accessing at an index, even though you can get an O1 element out, but you need to know the element, right, to get it out. And O1, like you can check if it is there in the hash set, that's O1. But to get it out, you really cannot in O1, like it will list it on its own, and that probably is an ON, which is not ideal by any means. But just to show that this can be done with hash set, is a hash set a good future practice, because everyone you'll see list, and they're using a like array list in Java or list in C#. So we're going to use a hash set just for the fun of it. Why not? Now for a key, well, we see that I have a stop 1, I have a stop 2, stop 7, 3, 6, and 7, right? Now 7 actually is traversed by both bus 0 as well as bus 1. Cool. So if I'm on 7 and then I can drop out. So basically 7 has 0 and 1. And these are buses. Whereas 7 is our bus stop. So from this stop, I can get 2 buses. Well, that seems like a good choice to make a key, like a bus stop. Because from this we can see we have two buses going to different way, and then we can just BFS by saying that whichever like bus go there, uh, then we can probably just do traverse it by taking, that's the little tricky part. Let's actually tackle it when we reach there, because I just don't want to be like kind of jumble around. So basically we create this graph, right? Then we do a BFS. We just say Q and Q is a source because that's where our starting point is. We make a visited because that's important not to duplicately like visit things again and again. Have stops, basically counting our stops. And then I just follow a BFS structure. So Q count greater than zero, size, Q count, int I is equal to zero, less than size, index. So what is this index? Well, remember in a queue, we put source. Our source is the bus stop, sorry, not number, bus stop. And this is the bus stop. Then I get the neighbors of this bus stop. Basically, by neighbors, what I mean is the buses that go to it. So buses that go to it. Here's a little bit more descriptive name. Instead of saying bus E, I'm gonna say bus numbers just so you guys can understand better. Cool. So that the buses that go to this bus stop, we get that in our set. Then we iterate with this set. We see if we already have seen this bus before, then we can just continue. If not, add it in our visited set because we see it now. Then have another loop, right? This loop actually is going to start with zero. And since this bus is basically, say one, say seven has basically buses zero and one go to it. So I'm just going to say routes zero dot length. That means I'm just getting over here zero dot length, and then I'm saying 0 comma 0, and then I'm saying 0 comma 1, 0 comma 2. And if any of this is equal to a target, which is 6 in our case, then I can just return the stops. Otherwise, I just enqueue this in our queue because remember, this is a BFS and we can enqueue the closest stuff. So 7 can enqueue both 1 and 2. Now, instead of considering them as something like 1, 5, 7, you should consider that this as 1 directly can go to 5 and directly can go to 7. So that way BFS would make more sense. If you just say this, you might get confused because you might say, oh, BFS travels the closest thing first. But the way we have structured it, we are tackling it like this. Anyways, so you enqueue this, right? So say we were on starting as 1. 1 would enqueue 2. 1 would enqueue 7. Then 2 is gonna get out. 2 cannot put anything in. Then 7 is gonna get out. 7 is gonna put in 3. 7 is gonna put in 6. As soon as 6 reaches, well, here's your target. Return the stops. So keep in mind 1 when puts 2, and then when it puts 7, that So say where first thing was 1 and Q has a size of 1. So it's gonna go to bus and buses that go towards the stop 1, which we only know only one bus go. So we go to that bus and we put 2 and 7 and then we come back right over the top again. Here our stops go plus plus again, so it becomes 2. Now once we are here, 2 is first gonna get DQ'd. Buses that go to 2 are still 0. Well, then buses, oh, just came across. Visited dot contains bus. So the buses that goes to it 0, 0 has already been seen. Continue, go towards 7. Now with the 7 buses that go towards it are 0 and 1. 0 has already been seen. I do not care about that anymore, so I'm gonna go to 1. I add it in my visited set. I go like buses 1 dot length and then add 3, 6, right? And then I add 3, I add 6, 6 hits this condition, I return. This is the tricky part of it, really. This much part, it's not this tricky. Basic DFS, this much part, modify the DFS, and also to see which one would be the key and which one would be the value is tricky. That's why I guess this problem becomes hard. You can also say this problem is medium hard and not hard. But yeah, that's the whole problem. And I hope you guys were able to kind of understand the solution a little bit better. And I'll see you in the next video.